Hello class, today we're on 3.2 multiplicities of zeros and end behavior. So I just want to touch on end behavior again. I know we already learned about it yesterday. But multiplicities of zero, that's something new to us. And multiplicities, what I mean is how many of zeros at one point. So here I have two examples. I have well, first let's just recall what a zero is. Remember, a zero is an x-intercept. A zero is also a root, x-intercept. Those are all the same thing. So we're really looking at where the function crosses the x-axis, the horizontal axis. So here I have two examples. I have an example of a function where it crosses the x-axis, and I have an example here where a function bounces off of the x-axis, just touches it and then comes back around, but doesn't cross it. Well, when it crosses, that means there's one zero there. But if it bounces, that means there are two zeros there. So that's what I mean by multiplicity. I mean, right at the exact same spot, right here, there's a zero. Here, there are two zeros right there. You can think, if it's in factored form, there's a square there on that factor. So let's talk about the multiplicity of zero by looking at a graph, and then I want to just again retouch on end behavior because it's a hard concept. So let's take a look at this left example here. We have a polynomial. We're asked what is x, and then we're given as x approaches infinity, f of x approaches what, and then as x approaches negative infinity, f of x approaches what. But let's talk about the zeros first. So I see that it touches the x-axis. I should probably label these. It touches the x-axis twice. It touches once right here, and it touches once right here. But knowing what we know about bounces, that means there are two zeros there. And knowing what we know about pass-throughs, there's one zero here. So this is at what? This is -2 and this is +2. So my x values, I have two of them at -2, so I need to label two of them. And then I have one at +2. Just like that. Now, as x approaches infinity, so as we go to the right, f of x is approaching what? Well, it's approaching positive infinity. So, I should have done this in a different color. This is positive infinity. And then as x approaches negative infinity, this is approaching negative infinity as well. So, also knowing what we know about it, I didn't ask about it, but we can say that this is an odd function, and a positive odd, just because of its end behavior. And I guess by how many zeros it has. So let's talk about this example. There are a few more points of contact with that x-axis here. We have one right here, here, and here. Well, I should say two right here, don't we? Because it bounces off. So let's see. Let's start with the left, -1, -2, -3. So it looks like I have two of them at -3 because there's a bounce. I have one of them at -1. I have one at +2. And then I have one at +4. So this has 5 zeros in it. Let's talk about end behavior. As x approaches infinity, f of x also approaches infinity. And then as x approaches negative infinity, as we go to the left, the function approaches negative infinity. Let's look at one more example here. So here we have another function. And it looks like here is a bounce and here is a pass-through. The bounce, we know there are two zeros right there. And at the pass-through, we know to be 1 0. Because remember, every time it bounces, there are two. And every time it passes through, there's just 1 0. So it looks like the zero here is in the center. So it's going to be 0, 0. And the reason I have two of them there is because it bounces. And then we have 1 0 at 4. And then again, looking at in behavior, as x approaches positive infinity, f of x approaches negative infinity. And as x approaches negative infinity, as we take the function to the left towards infinity, the function of f of x approaches infinity. So that's all I have for y'all today as far as zeros go. Just remember, every time it passes through, that's 1 0. Every time it bounces off the x-axis, there are 2 zeros at that point. So let me know if you have any questions. Have a good day. Bye.